So natural language processing and machine learning. How to automatically categorize tools and activities. That's a title if you are with me. Who am I? I'm Johnny RAHAJARISON. I'm developer at My Little Adventure. Here is my coordinates if you want to reach us or reach me personally. Don't worry, I'll give you the presentation later if you want. I try for the photo. Hey. Okay. So what we are gonna do today? Today we're gonna have a little introduction to machine learning, really quick because we had two previously. Then we will talk about why natural language processing is so hard. We will then go on how can we handle these obstacles and these troubles, and then have a quick demo. And finally, we have a conclusion with some resources that you can have and you can see later for yourself if you want to try things. Okay? So what is machine learning? I'll be real quick, sorry. But machine learning is the field of study that allows software to do something without being explicitly programmed to, just by learning through examples. So it means that you can use the same software or piece of software and just feed them with other examples and use it in various tasks. Okay. Previously, we talked about unsupervised algorithms and clustering. It's one of the two main traditional families and field of studies. But today we will talk a bit further about supervised algorithms. Supervised algorithms are algorithms when you have labeled data that you know, data that you can measure, data that you can train or explore by yourself. And supervised algorithms are algorithms that you can use to predict quantity, quality, and or classify. So I said we will talk about natural language processing. So why is text a tough task? First of all, text is very hard to process because, as we saw before, text is not numbers. But this is not the only issue here. Texts have polysemy. It means that a word can mean different things by the context, or even enantiosemy. It's the fact that a word can mean everything and his contrary. For example, I rent a car. Does this mean that I give a car to someone, or do I have the car? So that's a little bit of feel that you can have of why text can be hard. But I can give you a little exercise. What do you picture if I say, I saw a man on a hill with a telescope? I'll let you a few seconds. What do you see? This is not what I see. And this is one of the main troubles, because the same sentence, based on the context, based on the business on where you are, based on the word that you use, can be very tough. So now that we know the obstacles that we can have, how can we handle these troubles? As we saw before, again, we need to prepare our text. So I will be really quick about this, but we need to tokenize our corpus, our documents, into a way that our programs can handle this. So we tokenize our document into sentence, then into words. We can translate it. It means that we can strip or change our accents and so on. Just a quick word about filter out operations here, because it's the fact that you can remove tokens, and by tokens it can be stop words. Maybe for your application, a word like the or a or little or something are not relevant at all, and you can remove them, or maybe not. I can know. And you also can use a stemmer or lemmatizer. It means that it's a piece a piece of code or a piece of technique that you can use to change a word to his roots. For example, M, R, and is can be changed to B. So this way you can use all the variations of a word to his root element. The same thing for vary, that can be the translations for variations, vary, varies, variables, and so on. So we run all these steps, and we had these arrays of words. If you don't know it, this is the metamorphosis by Kafka. Now that we have words, we just need to have a way to associate them with numbers. Here, this is the technique of the bag of words. It's the same technique that we saw before, but a bit further. We take all of our words, we count them, we transform the words into their indexes, and then we have a transformation of our sentences into numbers, into an array of numbers. But there is an issue here. If we just count the iteration of our words, documents that are longer in terms of length can have more impact than smaller documents. So we came with this technique called TF-IDF, in which we, instead of just counting the numbers, we can count the frequencies of the numbers or the events. The TF operation here is to take the frequencies of the word, and the IDF is to put more weight to more rare words. For example, if you have a word that is really relevant for your business, the IDF here can help you a lot to find the real meaning of your word. But as we saw before, in 2013, there was this group of technique called words embedding that can capture relative meanings of words by changing them to vectors. So what do I mean by this is, you can see that on the figure on the right, you have above all female words, for example, woman and aunt, sister, madam, and below you have male nouns. But also you can see that woman and man are related, or madam and sir are related. So by this way you can, instead of just having numbers associated to your words, you can have relative meaning associated to your words because they are vectors. What do we do? Why do we use this? Because it can be helpful. It may be helpful. For example, here is a word embedding of country and capital, and you can see that you can do kind of equations. For example, if I take Paris, I subtract France, and I add China, what do I have? Beijing. And this is just through vectors. Okay? If you are curious, this is what it looks like. We associate every word to a vectors of n dimension, and here, for example, movies is by 300 dimensions, and by this way we can have all the words that are really close to movies, for example, cinema or film, or etc. Here is what we use, how we use this. This is not really like this, but you can have the same sense that previously. So now that we talk about the preparation of our text, we can try to use it for real. We will take a quick recipe that we use in machine learning nowadays. If you are curious, we did a talk about this. I can give you the slides later if you want to. So first we need to prepare and get our training data. Choose then choose a classifier algorithm, then try the classifier algorithm to make prediction, and finally measure it. So first step, we take our training and test dataset. For example, here we have projects. This is their titles. We have Eiffel Tower with diner, skip line with Eiffel Tower, etc., etc. And we want to predict them if they are food or not. So we take the label, we vectorize like we saw before, or like the presentation before said, and we manually said, okay, for example, this product is food, this is not, this is not, this is not, etc., etc. Now we need to choose a classifier algorithm. If you ask me, how do I choose? The answer is, I don't. I cheat. I cheat because I use a lot of cheat sheets, and you will have access to them later if you want to. But I have a few recommendations because I tried it a lot. So if you are curious and you want to see what works, at least this works well for me. Now that we chose our classifier algorithm and we run this, we can see some results here. For example, we can see that dinner cruise with champagne, the third row, is more food than Eiffel Tower with diner, because probably the word with means this is quite an option. And in the sentence, Segway tour of cities highlight is not food. And it's real, it's not food. But we can use it, and we need to use it, to predict the fullness of the real data. And this is what we saw. By this, we can see that Moulin Rouge Paris dinner show is quite food. Same thing for three-course meal in Eiffel Tower, but the Orsay dedication enchant is not. In my little adventure, we use it like this. So we have on the left all of our prediction, all of our features. For example, if you want to try, if you want to see the products that are food, outdoor, indoor, etc. And on the left, it's all the projects that have the filter that we saw. So here I search for food. We have algorithms that search and run predictions in all our documents, in the text, in the title, in the descriptions, in the short descriptions, maybe in the comments. It can be various ways. And we have food that are predicted on all our products. You may want to go further because you may have various troubles that are a lot harder than I said. For example, it can be really hard to get training data. For real, it can be really hard to get training data for your problem. Or you can have wrong user content. Maybe you can have misspellings or typos. For example, we had a lot of people that instead of saying we are going to Eiffel Tower, they were going to LF Tower. And LF Tower is not something that is real. You can also have memory or computing limitations, and so on. So I'll give you a few resources to try it on your own. The first thing here is our past talk on introduction to machine learning. The first is a tutorial of scikit-learn, which can make you exercise about how to work with text data. And the third one is a big list of cheat sheets. So when you can see techniques, algorithm, and so on and so on. I gave you also a few personal recommendations. My favorite book for data science, my favorite course, the dataset that I can use. The first one is a Project Nuremberg, and the second one is the Stanford Glove, a platform that I can use. It's called Dataiku. If you do not know how to code, but you still want to do what we did, you can use Dataiku for this. Or if you do know how to code, you can use scikit-learn, Keras, or NLTK to process data. So here we are. Do you have any questions? Yes.
You talked about training data sets. You showed it, I think, in terms of reference links that you use. But this was in English. Do you have any recommended data set for French?
For French, the question was the example of the data set are in English, but do we have something in French? I think that yeah. I'll give you later. But one of the most basic data set is Wikipedia. You can use Wikipedia to get training data set for lots of trouble.